Let's look more at this idea of redefining a function where there's an issue. In example number 28, we have g of x is equal to x squared minus 9x plus 14 over x minus 7. And the first question that we want to deal with is, where, if at all, does g have a discontinuity? Well, we know points of discontinuity are going to occur when the limit as x approaches a certain value of the function does not exist, or when the function itself does not exist, or when those two values, the limit and the function, do not equal each other. All right. Well, this is a nice clear function where we can see where the function is not going to exist. We know the function won't exist when we're trying to divide by 0. So what value of x is going to cause this function to try to divide by 0? Yeah, 7. Okay, so we are going to have a discontinuity at x equals 7. Why? Because we plug in 7 into the function, that means we have to put 7 minus 7 in our denominator, and that's going to be 0. Okay, so let's try to work around this. Okay, let's say that we redefine g. Okay, we're going to redefine g. Incomplete here. It's x squared minus 9x plus 14 over x minus 7, as long as x does not equal 7. Okay, because we have an issue when x is 7. So when x is 7, we're going to make that equal to q, a number, where q is just some very number that we're trying to figure out. Okay, what value of q is going to make g continuous at x equals 7? All right, we want a nice continuous function, but we have the discontinuity there at x minus 7. What value can q be in order to make it nice and smooth? How do we do that? We're going back to our algebra skills. Okay, we need to figure out the limit as x approaches 7. All right, which means that we have to use this function right here to see what's happening as x approaches 7. All right, so let's do that. Let's take the limit as x approaches 7 of x squared minus 9x plus 14 all over x minus 7. Now we know when we're taking the limit that we're going to plug this value in. But when we plug this value in, we get 0 in the numerator because it will be 49 minus 63 plus 14. Doing some quick mental math, that's equal to 0. In the denominator, we already know we get 0 there. So this is producing a 0 over 0 indeterminate form, which means that there's a good chance we can simplify this. So let's go ahead and use our algebra skills to do that. All right, we have x squared minus 9x plus 14. That's a quadratic. We can turn that into the product of two binomials. So we've got the limit as x approaches 7 of x and x, and we need two numbers, which are going to multiply to 14 and add up to negative 9. So what are those two numbers which will multiply to 14 and add to negative 9? Yeah, negative 2 and negative 7. So we have negative 2 and we have negative 7. That's our factored numerator. Our denominator is still x minus 7. Well, we can eliminate our issue now. The x minus 7s are going to cancel each other out. We're interested in the limit as x approaches 7 of x minus 2. Well, when we plug that in, that 7 in, we have 7 minus 2, which gives us 5. So the limit as x approaches 7 of our function is 5. That means our function is heading towards the value of 5. It's not equal to 5, though, yet, all right, because we can't plug 7 in. But with our new redefinition, when x is 7, we need a number right there. Currently, that number is q. We want an actual value. The value that we want is our limit, which means that q is going to be 5. Now we have a nice, smooth curve, or actually line, happening right here, because where we had our issue, we give the exact same value as the function was heading towards that issue. So q is equal to 5.